Hello, good afternoon, and welcome to our webinar this afternoon on overheating and Part O, where to start. My name's Adam Gravely. I'm Head of Technical and Innovation for the Future Homes Hub. Well, I'd like to start today by just a brief introduction in case you have not heard of the Future Homes Hub before, about who we are and what we do. We're an independent, not-for-profit organisation, part funded by industry and government and set up to work across the sector to promote sustainability of new build homes. In terms of how we operate, I like the phrase that you see on the screen here at the bottom, which is we bring together the right people to answer the right questions at the right time. We're all about collaboration, about facilitating collaboration with different partners across the home building sector. And you can see there that the pathway is laid out, and one of the things that we do is to develop these technical and operational solutions and overcome the barriers to get there. And the webinar today is an example of how we've done that. We're reaching out now to the sector, and I want to kind of acknowledge not only the speakers today who are experts in the field of overheating, and really they pulled together the guidance over the last several months. There is a steering group behind them and supported by our sponsors, Velux, the Mineral Products Association, and the NHBC Foundation, who make this possible. Also to introduce our speakers, firstly you'll hear from Susie Diamond. She was the lead author for CIBSE TM59, which is the methodology for overheating risk in homes, and also the Good Homes Alliance overheating risk tool, and that's going to be updated, I think being launched next week. And she will go through some of the technical and compliance aspects and introduce the guidance that we've put out there, really help you to understand what it is and how to best use it. And next speaking will be Richard Partington from Studio Partington. Richard's been working on low energy design practice, research and policy work for the last 10 years. Previously also as a member of the Zero Carbon Hub, he was on the steering group for this Future Homes Hub Part O project. And then we will look at, and Richard will look at some of the more practical design aspects and what the impacts on new homes are likely to be. And in the final section, we'll bring in Julie Godfroy, who also co-authored with Susie the technical guide, and David Adams, who's helped from the hub side, along with Tessa Hurstwin, to pull all of this guidance together. And indeed the calculator tool, which Tessa was heavily involved with. So again, thanks to our sponsors, and without further ado, I'll pass on to Susie Diamond.
Thank you very much. Oh, I need you to stop sharing your, there you go. Right. Hello, my name is Susie Diamond, and I'm here to talk to you today about the technical guidance that Julie Godfroy and I have written with the Good Homes Alliance for the Future Homes Hub on Part O, and the implications and the scope that it covers. Let's make sure he's working. Yeah. So a bit of background. Part O came into force in June this year with a few transitional arrangements, but most homes going forward are going to need to comply with the new approved document. It applies to all new homes, including care homes, boarding schools, and student accommodation. And it's aimed at reducing overheating risk. So it's sort of came about, I think, prompted by the Climate Change Committee and a growing awareness that overheating in homes has been becoming more of a concern and has implications for health and well-being of people living in those homes. And it was a recommendation that it was brought into building regulations. And here it is. So a good thing, I think, that we're now running that check against new homes. We do want all homes to be comfortable. So the Future Homes Hub have produced a range of resources really kindly to help with understanding this whole new building regulation. I'm here primarily today to talk about the technical guidance that Julie and I have written, but there's also a builder's guide, a where to start guide essentially, which is also available, and there are links coming up, and a spreadsheet tool, which we'll talk about a little bit as well. All of this sort of suite of useful resources to help guide you through the process. So there is help. I think that's the key message here that we're trying to get across, is that it is quite a big new change, but there's a lot of help and guidance available. So this technical guide originally published in July, but it's had a beautification since then, and it is free to download from the link given here. The Future Homes Hub website is quite easy to find. The first thing to mention, I think, and key to understanding it, is that there are two main routes to compliance on the overheating question itself. So there's a simplified route, which uses quite a prescriptive method based on measurements of glazing area and ventilation openings. And we'll talk a bit more about how both those methods work in the slides to come. But there's also a dynamic thermal modelling route, which enables you to use more sophisticated modelling tools and an experienced modeller, which gives you a lot more flexibility for how you go about that. So there's a sort of simple and a more complex route. Key things to bear in mind. Also, to think about right from the get-go, there are some key recommendations around designing to mitigate overheating risk, to make sure that's brought down to a manageable level. One of the key things in regards to Part O is to bear it in mind early. There are a lot of considerations that it will have a bearing on, that if you don't look at early and understand and make sure that you're compliant with it, could mean return to planning. A lot of these things will affect the facade, so what a building looks like in terms of glazing areas in particular and window configurations. So if those aren't taken into consideration really early on, you could cause you a lot of pain further down the road. Our best advice is to test archetypes as soon as possible. So if you've got some standard house types that you build regularly, to have a look at those, make sure they comply, and have a think about what you might do if they don't in certain situations, in higher noise areas or warmer parts of the country. Think really hard about maximising the opportunity for dual aspect ventilation. There's all sorts of positive reasons why that is a big one in terms of limiting and reducing overheating risk, from the fact that it enables cross ventilation and a much greater potential for ventilation through a property than having the windows all on one side. We know that single aspect is a really high risk, again, because you don't get the cross ventilation and because you're receiving all the solar gain at the same time of day. So that boosts it in that time of day, and that triggers overheating risk. And also because you lose the potential to locate bedrooms on, say, a quieter side of the building, which gives you that bit more flexibility and range. Other key considerations: reasonable proportions of glazing. This will come up quite a lot through the understanding of Part O. We all want to see generous daylight provision. That is a really important well-being feature, but designing that glazing to optimize the location and the design of the glazing, particularly with shading and enabling as much glazing as possible to be openable, are the sort of key things that will help you get through the Part O and deliver nicer, more comfortable, more user-friendly homes in the long run. And making sure that those are done in a secure and a safe way. As we'll see, those are quite key features of Part O as well. And not to forget other aspects of the building regulations, including Part L and Part F and planning, that are all focused on similar design concerns. So this is what we're going to cover in terms of the technical guidance. This is the main contents that the technical guide includes, starting with the overview. So yeah, as I said, the key things, there is a simplified and dynamic thermal modelling route that assesses the overheating risk itself. But on top of that, there are criteria around nighttime noise, security and safety, including falling and entrapment, which have to be addressed regardless of which route you're following. So those, we've got more slides ahead, and those are really key, and it's really important that you're aware that those apply no matter what other route you're following. They are requirements that you need to meet. Then thinking about the timeline, again, the technical guidance covers this in a lot more detail. All of this is covered in the technical guidance in a lot more detail. But thinking pre-project, early stage about testing standard units, having a think about how they perform, building a library of preferred solutions so that you know what you might go to as soon as there is some non-compliance showing up, and how you might prioritise depending on the severity of that issue. As soon as you've selected a site, highly recommended that you seek advice from an acoustic consultant. If nighttime noise exceeds the criteria within approved document O, there are implications, quite significant potentially, depending on how noisy, how much that exceedance is, but really important you know about it as soon as possible so that you can address it and do something appropriate. Thinking about early stage design up to the planning application, make sure that you've identified whatever passive design opportunities there might be, and that you've agreed the key design principles you want to follow. Agree the design of openings and other features so that they're all settled pre-planning and that they comply with the Part O assessment. You want to make sure that you test at least a good sample of units pre-planning to make sure that they're complying and that you've picked out the ones that are likely to be the worst case so that there's no, again, horrible surprises later down the line. And that you're not carrying those out in isolation. You're also making sure the same criteria are used in Part L and F and other assessments that you're doing so that there's consistency. Moving on to design development, engaging with building control well ahead of submission, checking with them that your approach is, that they're happy with your approach and the agreed sample that you've selected and the type of submission you're preparing. And then during construction and build, just monitoring for any change in tests that could impact on the final submission, that everything's still on target. Plus developing the home user guide and any particular information the home users will need to know about how the home is designed to cope in warmer conditions. Right, I know I'm gabbling, but there's quite a lot to get through. So moving on to the additional Part O requirements. So these are outside of the overheating check itself, but are really pertinent and you need to be aware of them. There are noise limits set for bedrooms at night. I'm not an acoustician, but I understand that those decibel levels are not especially high. So a lot of sites will exceed those criteria. One is looking at an averaged rate over the night time, and the other is looking at sort of peak noise events and making sure that, requiring that they don't exceed 55 decibels more than 10 times in a night. Now, what I understand is that even just being near a fairly busy road will exceed that, not necessarily being right by a train track or an airport or something we traditionally understand as big noise. So I think we're going to see a lot more acoustic advice sought. The good news is that the Association of Noise Consultants and the IOC have together written some really helpful guidance to their community. So acousticians are getting up to speed on what is required for this, and it should be fairly straightforward to procure an assessment. Passive solutions are often still possible if those bedroom nighttime noise levels are exceeded. It depends how much they're exceeded by, how much is possible passively. And if those exceedances are more significant, then it's likely that you may need to close all the windows tightly at night and move to mechanical ventilation or cooling solutions. However, it's important to notice that's at night, not necessarily during the day. And unless there's another planning issue that prevents the use of opening windows during the day, it's still feasible within Part O to use open windows during the day and then an alternative solution at night to address the noise criteria. So moving on to security requirements, windows that are relied upon at night for ventilation need to be secure. So these are windows that are on the ground floor or are easily accessible. So upper floor windows that can't be easily reached can still be freely opened. But if you're looking at ground floor bedrooms, we are looking at a range of different solutions in terms of fixed or lockable, louvered shutters, grills, railings. We've given some potential examples in the images below. I'm hopeful that designers will come up with lots more elegant solutions going forward. I think it is a real benefit to occupants if you live on the ground floor to be able to feel comfortable with leaving your windows open at night when you're sleeping. It's obviously a lot more pleasant. So, and obviously alarming if you don't feel safe in that scenario. So I think this is a positive, but there will be some challenges around achieving that in some circumstances. An additional key requirement is the protection from falling and sort of safety requirements. Now these supersede those in Part K, they're additional requirements, and they set out that a maximum reach on opening windows of 650 millimeters from the inside face of the internal wall of the wall. So that's not a limit on how wide windows are able to open, but it's a limit on how wide you can take account of them being open in the Part O calculation. And that's quite a subtle distinction, I know, but it means you don't have to put limiters, for example, that prevent them opening more than 650 mils, but you can't take account of any ventilation that is produced if they're wider open than that. So the good news is that the rather magic spreadsheet that has been prepared by the Future Homes Hub will take account of that and make sure that that limit isn't exceeded. The other one is on sill heights and ensuring that, well, the requirement is that sill heights should be higher than 1100 millimeters. And that means that restrictors shouldn't be required because the sills are higher than people can fall out of. But we're also conscious that there is a maximum sill height for windows that are a means of escape of 1100 millimeters. So there has been a small tolerance of 100 mils below the 1100 in Part O. This is all explained in the guidance, I promise you. I know it's fiddly, but it is important to be aware of because a lot of standard window designs, and this again is upper floor windows, not ground floor, but any upper floor windows will need to be mindful of these two requirements, which could be quite significant. So bringing your attention to those, and there is a lot more advice around these in the guidance. So moving on to the nitty-gritty of the actual overheating checks, two methods. The simplified method. Now, this is a bit of a misnomer because it's not nearly as simple as it sounds, or it should be, in my opinion. We've created a flowchart that sort of guides you through the approved document and all the requirements that it lists out. It essentially asks you to set the targets. You just determine what your targets are based on some characteristics of the home, and then you assess whether or not you're meeting those targets. So it's a little bit of an involved process, but the good news is there is this free spreadsheet tool that the marvelous Tessa Herstein, I think, has had a lot to do with, and I've got a few screenshots there. You'll have to download it for free from the Future Homes Hub website, and that takes you step by step through this process and helps, I think, a lot with the sort of error checking and making sure that you're doing it in the right way. So what you end up having to do is the measurement side, so there's no escaping that. Oh, and a key aspect of the simplified method is that you do need to assess every single unit on a scheme. So it's not done on a type basis or a sample basis. You do need to do every single unit because every unit might have a different orientation and a different configuration. So I guess if you've got exactly identical units and facing the same way, you could copy and paste, but be mindful of that. So you need to take measurements for the glazed area of every window pane. So that excludes the frame and is just purely the glazing. The width and height of the opening, so that does include some of the frame. The floor area for each room, so each occupied room. the gross internal area of the whole home, and then the equivalent areas, which is the ventilation area, effectively, is calculated by the spreadsheet. So that's a good news, because that's a fiddly one. Is that everything I need to say? Oh yes, and the spreadsheet will also work out what your targets are and whether you're passing or failing against each one, and give you a nice little printout of how that unit performs, so that you can identify any areas where you need to do some extra work. So that processing of the results is also a really key feature and a really helpful inclusion in the tool. So moving on to the dynamic modelling method. So the change here is that you only need to assess a sample set of units. So your modeler can help you assess what a reasonable sample might be, a representative sample that would include those likely to be at the most risk of overheating. The method follows the CIBSE TM59 methodology, which I was an author for, so I do know quite a lot about. But that sets quite a clear process that modelers need to follow. There are two key criteria within CIBSE TM59. Sorry, I know I'm gabbling. One based on adaptive thermal comfort that looks at all occupied rooms, and the second that looks at bedroom temperatures at night. So, you know, there is a similarity with a simplified method in that respect. Your modeler should be able to give you some commentary on spaces that don't meet those criteria. So this is the way I present my results in the box at the bottom, so you can see where the exceedance is coming in, the numbers that are going red, and it highlights the rooms in which fails are occurring, so that you can identify the cause behind that and what mitigations might be appropriate to improve the design to the point where you do pass. One key thing to bear in mind, I think this might be on the next slide as well, is that blinds and curtains are not allowed to be included in the TM59 assessment under Part O. Used to be under TM59 CIBSE method, but that's quite a big one, because that often made quite a big difference, particularly in city centres. I'm thinking London particularly. One of the big advantages of the dynamic thermal modelling method is it takes into account the location in more detail than the simplified method, which only looks at central London and the rest of the country. Essentially, there are some small bits of Manchester that it counts as high risk, but weather data actually varies quite considerably from one end of the England to the other, and therefore if you are in a building in a site in the northeast, for example, you're likely to have a lot cooler microclimate than if you're building in Guildford. So the dynamic thermal modelling method, because it picks a weather file closer to your site, does enable that to be reflected, and wind speeds and air temperatures and solar gain and all sort of reflect that local climate in a bit more detail. The modelling method also enables you to take more design options into consideration. So it looks at ceiling fans, for example, external shading devices, and will allow you to take into account mechanical ventilation. So this is the method that you need to use if noise levels are exceeded. Mechanical ventilation at night, and or potentially mechanical cooling if that's absolutely necessary. I think I've covered the differences to the original TM59. So whichever method that you follow, there are reporting requirements. I know I'm running out of time. There is a compliance checklist within the approved document, and a lot of that's been replicated in the spreadsheet tool that the hub's produced, and that gets filled in for the simplified method if that's the route you're following. If you use the dynamic modelling method, then a full modelling report will be required to be submitted, and your modeller can help with that. In terms of the rest of the guidance, it also includes some basic good practice principles, which I think I covered some of earlier on, about designing for limiting overheating risk. It includes some detailed worked examples following a project through both the simplified and the dynamic modelling route, to show how that works through. And it also has 4 case studies looking at different scenarios and how they were enabled to comply with the approved document. For additional resources, just in case these are useful for you, DLUC have put together a list of FAQs that sort of give additional information on the questions that a lot of people have been asking about the approved document. So they're published on the DLUC website, and there's a link there. The Good Homes Alliance, Julie and I wrote for the Good Homes Alliance a few years ago now, a one-page tool for new build homes, which gives some really early indicators and some sort of broad brush themes about where overheating risk comes from and what the appropriate mitigations are in different scenarios, and what might help to better design homes that don't overheat. And very recently, Julie in particular has been putting together a retrofit version of the same tool, which is a bit more detailed and aimed at existing homes and retrofit, the launch for which is next week. I mentioned earlier the acoustic guidance has come out, and also there's a reference to TM59, which you might need to swat up on, although your modeler should be fully aware of all this. It's the advantage of employing an experienced modeler. I can take you through all that. So that's everything I wanted to cover. Sorry, I know I've gabbled because there's a lot to get in, but if you've got any questions, do feel free to fire them at me at the Q&A later on. I shall stop sharing. Over to you, Richard.
So, good afternoon, everybody. My name's Richard Partington. I'm an architect and designer, and I'm just going to give you a short talk on some of our kind of collective thoughts about how some of the implications from Part O will actually apply to how homes look. And you will have gathered from that fantastic talk from Susie that Part O is pretty complicated, both in interpretation and in its application. But there are some basic underlying principles which, if you can understand, give you a good idea of how things might change in terms of the design of homes. So what Part O is encouraging us to do, firstly, is to limit overheating that's caused by solar gains. So keeping out unwanted summer heat, either by making windows smaller, or by shading them in some way with some kind of device like a shutter, or by changing the specification of the glass so that it reduces the solar transmission. So the first thing is trying to keep the sun out. The second thing is it's encouraging us to improve the ventilation in homes, and especially on the bedroom floor, because it's likely that at nighttime during sleep, occupants of a home are likely to most feel the adverse effects of overheating. And then the final kind of series of things that Part O is asking us to do, and this is very unusual because it's the first time in the building regulations really, is it's asking us to think about the context of the home. So a home that's designed to work in the middle of a green field might not necessarily work in the same way in terms of Part O if it's on the edge of a site next to a railway line or a motorway. And with the encouragement to improve ventilation, there are all the considerations about how you make that ventilation safe, which Susie has described. And the one that as most obviously stuck out as a kind of change to the way we design, and it's something we encountered actually when we first started to look at Part L for the Future Homes Hub, is that the limitation, and it applies whichever method you use to demonstrate compliance, the limitation and constraints on the way that windows are designed on the first floor bedroom. So this business of the 1100 guarding. And what we found generally in the modeling work is that on the whole, upper floor windows, we needed to make sure that there was enough ventilation and the ventilation area of the window was sufficient. And so the likelihood is the proportion of windows on first floors are going to change. Because of the 1100 sill, the window will be wider and the window will be less deep. Of course, there may be other clever ways around the requirement, for instance, having a fixed panel of glazing below an opening window. But the way Part O would see this doesn't necessarily help the designer. So the fixed panel is letting the sun in, causing solar gains, and the upper panel is reduced in area, so it's reducing the ventilation. So it needs quite a lot of trial and error, whichever tool you use, to try and work out the best combination of balancing those two requirements, limiting overheating and improving ventilation. So there are not many homes that are built to the Part O standard, but looking at the sort of portfolio of things that we've been working on and refurbishments we've done, these are studio flats that have been designed with 1100 sill. And of course, the studio is also a sleeping space, so you would expect that regulation to apply. And the overall daylighting quality is quite good in the space. There's good daylight from a full width window. But if you think about sitting on the sofa, the condition when you're sitting down, there's actually no views out from that room. And there are some concerns about just the impact of that particular requirement on the qualitative aspects of kind of upper floor and bedroom spaces. Now, one of the great things about the guidance that the Future Home Hub has issued is that there are, in section 8, a series of case studies where you can see how an existing house design has been transformed or modified by applying either of the tools, the simplified method or the dynamic TM59 method. And it begins to give you an idea of where there will be some design flexibility and where, in the case of the simplified tool, it's a rather crude application of some sort of simple principles and sort of leads you more towards reducing window areas. And this is an example of where TM59 has been applied. And you can see it allows you to analyze the opening of different openings within the home with different characteristics. So for instance, opening vents that open a certain amount during nighttime, doors that can only open during the day and not during the night, and then windows with louvers on the outside. And so TM59 is probably the likely route if you're wanting to apply some design flexibility and take the view that window areas and internal daylighting, for instance, might be a priority, and mitigation has to be applied through a more sophisticated design route. And I think our conclusion from the work that we've done so far is that if you adopt the dynamic thermal modeling TM59 route, you should see that really as part of the design process. It shouldn't be just seen as a compliance check, because there's lots of useful information comes out of doing the model that helps inform the design process. One of the things I think we will see are more instances of sort of shading and external guarding. And Susie mentioned the difficult problem you have on a ground floor, especially where you've got bedrooms, of providing enough security. But this is also going to introduce quite a significant cultural shift. So in Europe, you often see external shading, and of course, the shuttered traditional Mediterranean homes on the cover of the TM59 guide are absolutely a vernacular response to a hot climate. But of course, it means that all of the windows open inwards. And so our obsession with curtains and decorations on windowsills and things is going to be slightly limited if this is the approach. There are various mechanisms for dealing with, the difficult to deal with east and west sun, where the sun angle is low. And again, you need the expert advice of a modeler or somebody who is able to fully understand the design and solar orientation and aspect of homes like this. So here we've got a west facade with a vertical projection and a deep set window. So you can see the recess at the window reveal is providing some shading on the left hand of the window, and the projecting fin is also providing some shading on the fixed panel to the right. That's a little bit easier to comprehend and certainly easier to control is south-facing sun. So projecting balconies that project out towards about the depth of the window. So in other words, cutting off sun at an angle of around 50 degrees can deal with the highest level sun in summer. So you can have a projecting balcony or a projecting shade that allows some useful winter solar gains, but also keeps out the unwanted sun in the summertime. So now here's an example of what we discovered when we applied the simplified method to some dual aspect apartments. So this is in London, so high risk, but dual aspects, so potential for good ventilation. And you can see on the left here, the elevation of a 3-floor sort of walk-up maisonette building with a bedroom on the right-hand side, a large fixed panel and opening vent, and then a living room with a fixed panel and opening doors. And to get this to comply with the simplified method, you see there's quite a significant reduction in the glazing area. So an increase in the ventilation to the bedroom, but overall a decrease in the glazing area to reduce the solar gains. Quite a substantial change. And this is the output from the tool, the spreadsheet tool. So you get an idea of where, having put all of the input data in, where the vulnerable rooms are or the facades that are causing a problem, or the areas of glazing in the specific rooms. And of course, there are more sophisticated ways of tackling that problem. So if the design priority was to keep that amount of glazing, then for instance, the balconies, as in this design, can be partially enclosed. But then there are issues to do with communicating to the residents how these sort of devices are used. So something like a winter garden here in wintertime, if it's sealed up, it protects the home from quite an exposed site, makes the winter garden and the balcony more usable during the winter. But in the summer, the whole thing has to be opened up to ensure that you can achieve the necessary ventilation. And that modeling can only really be done by somebody who's used to the dynamic thermal modeling and understands the criteria that are being applied and the impact of different changes. So here's an example from our own work, and this is a project that's been completed some 10 years ago with Barrett and David Wilson Homes. And here we were designing homes with several considerations really, but if you look on the right-hand side, you see large areas of glazing that actually front onto a winter garden. And the point of the winter garden is not only to mitigate overheating, it was also to do with introducing some privacy on homes that were very close to a street frontage. So where there was a ground floor living room, having a buffer space. It was a buffer space environmentally, so helping with the heat demand in winter. And it was also a device to allow a through-floor lift to be incorporated within design. So in this space here, so that we could provide for future adaptability and flexibility without putting a lift through the center of the living room and the master bedroom. But one of the things that it did do, and it's been very successful, is allow for some ventilation to the ground floor, but in a secure way. So the residents can open the first floor windows in the winter garden. The air can move through from the garden space through the first floor and through the ground floor. And those windows can be left in a secure open position when the home's not being occupied. So here you can see the first floor grillage is actually an open mesh. So this is providing some shading for the windows below, but it's also providing a method, you can see it's open, for air to pass through the home. So you might think this is quite an elaborate solution really for a problem that could be solved by just reducing the window area. But actually one of the things that we've discovered on this project, and we revisit it regularly over the whole course of the work, and we're now on the 5th phase of 13-year building program, is that the single thing that everybody says who has a home here is that they really appreciate the lightness and the airiness and the spaciousness of the homes. Now, in fact, the homes aren't particularly spacious. They really don't exceed the national standards by very much, but they do have high ceilings and they do have plenty daylight. So there is a perception of spaciousness. And I think we need to think about ways of applying Part O and taking the risk of overheating with future climate very seriously, but at the same time trying to preserve some of the attributes of homes, you know, especially in an environment like York where winters are pretty grey and miserable and wet, and the site itself is quite exposed. So a final example, and here all the alarm bells should be ringing. And this is high risk at its most risky. So this is a series of buildings that we're involved in, designed around a new public space at Putney Station in southeast London. And you can see in the foreground the tube line, that's the district line, so running right late into the night, beyond 11 o'clock at night. You can see a bridge just beyond the tube. So that's a branch line that connects Waterloo with Clapham Junction. You can see the cars in the foreground, that's the South Circular. And the fourth part of the site that you can't see is the main line cutting into Waterloo for the Southwest line. So all of the things that would trigger warnings about the potential to be able to open windows. So it's noisy, it's potentially polluted, coupled with the fact that we had west-facing facades and we also had single aspect units. So we thought this was a good project to try out on some of the modeling tools. And I think you'd agree when you just look at the facade, this is absolutely standard sort of design fare in London in terms of the proportion of glazing and the proportion of brickwork and the kind of design aesthetic. So the so-called London aesthetic, kind of largely well-proportioned glazed areas. And again, part of the market demand from developers and from purchasers for plenty of glazing and good aspect. And so the elevation, and you can see here, single aspect, 2-bedroom apartment. So master bedroom has doubled windows, smaller bedroom has single windows with a fixed vent below, and the living room has a pair of double sliding doors. And throwing all the tools at our disposal through TM59 at it. So this isn't the simplified method, this is using more design flexibility. This is what we would end up with. So you can see there is a real significant issue on these high-risk sites of how we manage the potential for overheating on certain elevations. And I think one of the concerns as well for designers is that in the urban sites, it's not just external factors, so solar gain, that is beginning to cause a problem with overheating. We also find that the accumulation of heat inside the buildings, so especially associated with things like communal heating systems, but also to do with the high occupancy per square meter area, are causing problems with overheating. So mitigating the issues of solar gain from the outside, we need the measures that are now on screen at the bottom right. So reduction in window areas, reduction in window heights, a change in the opening mechanism of the windows from sliding windows to paired casements, so we can increase the ventilation. And here is the project as it was completed. Now, actually, this was designed before Part O, and we were anticipating some of the problems to do with overheating because we were quite aware with working the practice of difficulties with communal heating. And I would suggest that whoever is designing in these urban environments, that we think very hard about, for instance, coupling a ventilation system in common areas with heat distribution. So in this building, we have a fire engineered fire strategy, and all of the corridors and common spaces are mechanically ventilated, and that ventilation system is also part of the smoke extract system. And in fact, the two are quite complementary because running the ventilation during the summer is a good safeguard to make sure that in the fire condition, all of the extract systems are working efficiently. And in other projects in the practice now where we don't have the benefit of that fire engineered solution, we've pretty much outlawed any horizontal distribution of hot water pipework. So we're distributing hot water for heating and hot water in homes in much the same way as you would in a hotel, where you're running vertical rises with paired apartments, and you're avoiding that accumulation of heat in common areas and common corridors. My final thoughts, though, are to do with where we might end up with when Part O is applied. And the reason for showing you the Dowenthorpe houses and that rather elaborate winter garden is really with a hope that the response from designers and developers is not that you just look at a house type and look at the worst condition, in other words, the most glazing when it's facing west, and design a solution with smaller windows in order to satisfy that criteria. That seems to be part of the solution to overheating, but not part of the solution to providing generous, well-proportioned, spacious homes that people like. And the problem in the urban areas is likely to be more extreme. So this example, for instance, I don't think we would get through planning now if we were to apply the mitigations that I showed you in that modeling exercise. So one of the planning criteria on this site was that we met certain daylight and sunlight criteria on all of the homes across the whole of the scheme. And that's a very common requirement in dense urban development. We want to make sure that homes lower down on the lower floors are getting sufficient daylight and have a view of the sky. And that is in direct conflict with the impulse from Part O to reduce glazing area. So how will that be solved? Well, one fear, and part of this fear is perhaps because of the slightly uncertain wording of the guidance in Part O, is that developers will resort to mechanical cooling very early on because they can't get all of the things to balance: daylight, sunlight, solar gains, noise, pollution, mechanical vent. You could end up with a lot of active cooling systems. And of course, that's completely the opposite of where we want to be in dense urban development. If you're applying active cooling, you're taking heat out of some buildings and dumping it into the air in the immediate environment near other buildings, and increasing the propensity for the urban heat island effect to happen in city centres. So I think there are some real challenges, and I can see in the chat there are already lots of questions about the clarifications that have arisen, and you'll see in the presentations, and especially in the guidance, wherever there has been a clarification from GLUC, we've tried to answer that with a direct reference to the FAQ. But the fact that there are so many questions that have been generated means it's going to be quite a while until we understand really how to apply Part O and what the implications will be. So the next part of the webinar is a Q&A session. And I think I'm just going to hold this slide on until Adam is taking over and chairing, and then I'll turn off screen sharing and turn off my audio.
Thank you, Richard, and thank you, Susie. Fantastic to have those presentations today. Much appreciated, and welcome, Julie and David to the panel. So we'll have a conversation discussion based on some of the questions that have been raised in the chat today, and also, as you mentioned, Richard, some of those questions that have been flying around in recent months since the introduction of Part O. If I start with you, actually, and some a simple one here, just in terms of the guidance that's out there. So people were looking for the spreadsheet, and the guide will add that at the end. It's on the guidance page of the Future Homes Hub website, and the flowcharts available for use. Yes, they are within the guidance itself. Susie, if I can ask you first, there was a question about shutters. Can the shutters be fitted internally only using both methods?
I'm not quite sure how that internally only. So external shutters are usually the preferred option because you're shading from the outside of the building before the solar gain has sort of penetrated. So external shutters are the sort of gold standard. Excellent, yes please, if you can. Where that's not possible, what I understand is that DLUC have approved that fixed internal shutters can be applied within TM59, so you'd have to use the dynamic modelling method to take account of them. You would also need to take account of any impact they'd have on the flow rate through the windows, so you just need to make sure that you've got the discharge coefficient for that product kind of from the manufacturer and input it into the software, because obviously once they're shut you're going to get a lower flow rate through the window. Does that answer the question?
That's great, thank you. And on a similar theme, there was a question about security, and can you use long, narrow and shallow windows for secure ventilation, i.e. not accessible by a burglar because they're so narrow? Is there any provision for that?
See, ideally I'd say yes, but I think it's got to be less than 100 mil openings, which is quite narrow. So unless you're really talking about less than 100 mils, then possibly not.
Yeah.
So Adam, the problem with that solution is that you would have to couple a number of windows together to get sufficient ventilation. And that means that you'd end up with as much frame as you would end up with window. So you'd be really struggling to get the free area of the opening. And you saw that a little bit in the first example I had of the house that had lots of multiple vertical windows opening. It's not easy to solve it if you take that approach.
Thank you, that's great. If I can bring Julie in and just ask the question, the simplified versus dynamic method, there was a question on the chat about what determines which method should be used.
So there are some cases where it is chosen for you, and others where in effect it is. So for example, in theory, you could use the simplified method even if you exceed the noise limits. In practice, it's very unlikely that you would, because you wouldn't essentially get your free areas. You just wouldn't be able to show that your free areas are met. So in practice, on noisy sites, you'll have to use TM59, and then there's a certain number of conditions where it is decided for you. So for example, if you have long corridors with heating running through them, then you have to use TM59 so that your assessment looks at the whole building and the impacts of the corridors on the apartments as well. I would say that in practice, unless it's, you know, a one-off house, if you're talking about a large scheme, either you already have sort of typical designs that you've already tested and you're pretty confident about how to make them work in the simplified method. Otherwise, if you're looking for design flexibility, it will be quite time consuming and limiting to use the simplified method.
Great.
Susie, maybe you want to add.
Thank you.
No, I think that's a good summary. There is a table, I think, in the where to start guide. There's a bit of a flow chart that indicates, you know, some suggested for which method you use, and that obviously there's quite a lot of guidance in the technical guide that we wrote.
Yeah. Thank you. And the questions are flying in thick and fast. So David, if I can ask you also, as your company that are related, or
yeah, I'm keeping ahead of them, so you keep going, and I'm noting those, and you can switch to me whenever you like.
Great. Okay. Thanks. So there was a couple of questions before about ground floor windows, and particularly things like changes of levels, and whether you what the security restrictions are for window and patio door opening angles on the ground floor. I'm not sure that question is framed clearly.
If I may, on many of these, the points in Barto are a nightmare to read and understand.
Yeah.
So we spend months trying to clarify them in our guidance and in simple diagrams. And you also have some nearly comprehensible English in deluxe FAQs. So I think if we try to explain some of these now without the actual diagram, we're going to confuse everyone.
But I could add to that, Adam, it's been really difficult to understand the intention. But just to give you an idea of how you would try and solve the ground floor problem, if a window opened over a public thoroughfare or pavement, you'd look to part M. If the change in level was less than 600 mil, you'd look to part K. If it was more than 600 mil, you'd change a window like an upper floor bedroom window, like part O. And if it was a patio door, you'd have to ask the building control officer, because it doesn't answer that question. So it is really not straightforward.
Yeah, thank you. And there is another question here for you, Richard, about the high risk case that you demonstrated. And the question was, the final building doesn't seem to incorporate the amendments that you recommended on the elevation drawings.
That's right. It was designed before Part O, a long time before Part O. And so we were really using it as a test case to see what would happen if you applied Part O. Now, what we actually did on that building, because of that difficult urban environment, is that we have a slightly unusual centralized extract system. And you'll see, if you look at the case study in Susie and Julie's guide, they not only look at the mitigations to the external facade, but they look at what kind of ventilation would be needed for each of those mitigations. And we do have a fairly robust solution by having centralized extract and oversized ventilators, acoustic ventilators. But we've created another problem in wintertime, because we're moving so much air through the building in summer to deal with overheating, that we need to explain to residents how they modify that air movement in winter, so they're not just dumping loads of cold air into a really well insulated building. So these things, I hope people are beginning to understand. There are lots of interrelated design issues, which is why your advice on overheating should be design advice, not compliance advice. You really need help from somebody who's really good at building physics and building modeling to understand these interactions.
Thank you. David, one from you.
So I'm going to try, we've got so many questions, so let's just answer some quite quickly if we can. All right, we'll see if this works. So to Susie or Julie, how are dynamic / manually operated solutions, i.e. winter garden balconies, valid since they rely on human activity? Is this something that requires TM59 modelling to be accepted, or can they be defined under the simplified method, we should say, I guess?
Well, it's a tricky one. It depends. I'd have to look at the design. I think on the whole, it would be hard to get the full benefit represented in the simplified method. It's possible if the areas, the glazing wasn't enormous and the opening areas were really generous, that it would comply with that method. But it would probably be better represented using the dynamic modelling in terms of that particularly the cross ventilation flows and so forth, would be better represented in TM59.
Sounds sensible. Yes, we're going to share the slides, Adam, after the presentation. Can someone go into more detail about window opening limitations, particularly on ground floors for bedrooms, briefly? How about Julie? No,
Julie said you really need to read the guidance because it is really fiddly.
With diagrams.
Look at the diagrams. It's really hard to explain succinctly without missing a bit, because just as you sort of pack it all in one place, it pops out somewhere else. So I think essentially be really wary of ground floor bedroom windows. You do need to pay attention to the security aspects. They apply at night, especially. So what you can open in the daytime might be different to how much free area you can achieve at night. The spreadsheet will help you calculate that, or your modeler. So this is where modelers are really going to have to step up and know their stuff and provide really helpful, positive, proactive advice. But yeah, it is a tricky one.
Okay, another couple of quick ones. Can restrictors be used for security? And related, are tilt and turn internal windows a valid option to address security?
So DLUC were very clear that restrictors they do not consider safe. We even showed examples of high-level narrow openings with restrictors, and that was not deemed good enough.
They have to be actually lockable in the open position, but yeah.
Yeah, we've got a longer question here, which is a bit more philosophical about Part O. So I'm going to jump that because we really don't have time. Great question that it is. Yeah. Will PHPP be a recognized calculation method to demonstrate a building is going to not going to overheat, as it's very detailed, blah, blah, blah.
And David, beware, if you're running PHPP, you can get the overheating check in PHPP to work, but the building will still fail Part O. We've already fallen foul of that. So
thanks, Richard. Absolutely. Yeah. And another one that we've batted around a lot: would the higher sills at first floor not go against approved document M requirements, wheelchair dwellings?
Yes, is the short answer, because the handles will be in not a very useful position for somebody who's in a wheelchair.
So we flagged that up specifically, and in our guidance there's a specific section that proposes solutions to that specific point. So thanks to Levitt Bernstein, who developed an example. I think the assumption first was that this wouldn't happen very often on the first floor, but we developed something that DLUC sort of approved, which is in our guidance.
Great, thank you, Julie. So look at the guidance. These are great questions, and believe you me, the reason we've taken 2 or 3 months, probably 3 months developing it, is because you can see all the questions coming through now. Some new ones, have to say, but
I told you there'd be loads of questions.
Absolutely. Won't fitting shutters result in people having the lights on more and therefore consuming more energy?
So
potentially, but they can be hinged shutters that you can open when it's not hot. But yeah, if it's hot and sunny, I mean, all the advice recently when it was really hot was close your blinds, your curtains, your shutters during the day. And yeah, you would have to put the lights on if you're indoors at that point, and then open them up in the evening when it's cooler. So potentially, yes.
Thank you, Susie. And I would say that the benefit of all of these questions that we've been throwing around is in the guidance. So please go to the website, download it, and have a look. And if there are more questions, then get in touch, and we are happy to help as well. So thank you very much to our speakers today, to Julie, Richard, and to Susie, and also to David. Thanks to our steering group and all of the industry experts that have advised behind the scenes and been part of creating this guide. Once again, thanks to our sponsors, to Velux Concrete Centre and HBC Foundation, and also to the Good Homes Alliance, who have supported with this process all the way along. So thank you, and we'll leave it there.